All right, let's do this. Today we're going on a quest, a mission really, to unlock the secrets behind every potion, every sports drink, and even that perfect cup of sweet tea. We're going to master the science of mixing things. So are you ready to become a solution master? Let's dive in. You ever follow a recipe for a drink and wonder, why are the measurements so specific? Well, guess what? It's all chemistry. And understanding how to mix things the right way, it's kind of like having a science-based superpower. And trust me, by the end of this, you are totally going to have that skill.
Okay, so every great quest, every video game starts at level 1, right? You've got to learn the absolute basics. So that's where we're starting. We're going to master the 2 fundamental building blocks you'll find in pretty much every mixture you'll ever make.
First up, we've got something called the solute. Now, don't let the word scare you. It's really simple. It's just the stuff. You know the stuff you mix in. So if you're making lemonade, your solute is the sugar and the lemon flavor. It's the ingredient that brings all the punch. And what do you mix all that stuff into? Well, that's the solvent. This is your base liquid, the main event. So for our lemonade, the water is the solvent. It's the part that does all the dissolving. Easy enough, right?
And when you put them together, you take your solute, add it to your solvent, and bam! You've got a solution. The stuff just disappears into the liquid, and it all becomes one uniform thing. And that simple formula? It's the secret behind everything from the salt water in the ocean to the soda in your glass. Okay, level 1 complete. You've got the ingredients down. But a true solution master knows you can't just throw things together. Nope, you have to measure it. It's time to level up. For level 2, we're going to explore the 2 main ways to measure a solution's real power, or what a scientist would call its concentration. So these 2 paths are called molarity and molality. And yeah, I know they sound almost exactly the same, but they measure things in slightly different ways. And knowing that difference, well, that's absolutely crucial for unlocking a solution's true potential. First, let's talk about molarity. That's the one with an R. This is probably the most common method you'll see. It measures the amount of solute, your stuff, compared to the total volume of the entire finished solution. Think of it this way. You make your drink, pour it into a 1-liter bottle right up to the line. Molarity tells you how much powder is in that full bottle.
Now let's look at molality with an L. This one's a little different, kind of sneaky. It measures the amount of solute compared to the mass, like the weight, of just the solvent you started with. So before you even mix, you'd weigh your water in kilograms. It's all about the ratio of your stuff to your starting liquid, not the final product.
Okay, so you might be thinking, why on earth do we need 2 different ways to do this? It seems a little complicated, right? Well, here's where it gets really interesting. It all comes down to one simple question. What happens when you change the temperature?
Let's imagine we use molarity to mix our potion. We fill the bottle perfectly to the 1-liter line, it looks great, the concentration is exact, but what happens when things aren't so perfect?
Here's the catch. When that solution gets warmer, the liquid actually expands. It takes up more space. So suddenly your perfectly measured mixture is over the 1-liter line. The total volume has changed, and that means your molarity measurement is now wrong. Whoops. So this is the big takeaway, the really crucial point. Molarity is based on volume, and volume changes with temperature. But molality, it's based on mass. And guess what? Mass doesn't care if it's hot or cold, it stays the same. That's why molality is the hero for precise experiments where the temperature might be all over the place.
You know the ingredients, you know the secret measurement techniques. It is time for the final level, the boss level. We're going to use this knowledge to unleash the hidden superpowers of solutions. Scientists call them colligative properties. So what is a colligative property? Basically, it's a special change that happens to a liquid just because you dissolved something in it. And here's the wild part. It doesn't matter what you add. It only matters how much you add. The more little particles of solute you have floating around, the stronger the superpower gets.
Now, there are a few of these powers, but today we're unlocking 2 of the absolute coolest. The power to make liquids boil at hotter temperatures and the power to make them freeze at even colder temperatures.
Let's start with boiling point elevation. You've definitely seen this in action. Ever watched someone add a bunch of salt to a pot of water for cooking pasta? By adding a solute, the salt, you actually make it harder for the water to boil. It has to get even hotter than usual, which means the water's hotter when it finally boils, and that helps cook your food faster. You've just elevated its boiling point.
Now for the opposite power, freezing point depression. Think about an ice cream float. The ice cream is our solute, right? It's packed with sugar and other stuff. When you add it to the soda, it actually lowers the liquid's freezing point, and that makes the whole drink feel extra frosty and super cold. It's the exact same reason we put salt on icy roads in the winter.
And that's it. You've done it. You've completed the training, you've faced the challenges, and you've leveled up your knowledge. You are now officially a solution master.
Let's do a super quick recap of your journey. First, you mastered the basic ingredients, the solute and the solvent. Check. Then you learned the two paths to power, molarity for everyday stuff and the temperature-proof molality for precision work. And finally, you unleashed awesome solution superpowers like boiling point elevation and freezing point depression. Nicely done.
You know, the most important thing to take away from all this is that a solution's real magic isn't just about the ingredients themselves, it's about the ratio. It's about seeing those hidden rules that connect everything from your kitchen to a high-tech chemistry lab.
So I'm going to leave you with a final challenge. Now that you're a solution master, what other kitchen superpowers can you find? Take a look around next time you're making something. I bet you'll start seeing the science absolutely everywhere. Now go explore.